Solving quadratic inequalities. All right, so today's lesson, there's only one standard, which is rare, but anyways, one state standard that goes along with this. And to be successful today, you need to be able to solve quadratic inequalities algebraically and graphically. Your vocabulary term for today, a quadratic inequality in one variable. X can be written in one of the following forms, where A, B, and C are real numbers. A cannot be 0. So you've heard me say this before. If A is 0, there is no quadratic. There's no x squared. Without an x squared, it would be a linear equation or inequality. So it has to have an A value to be quadratic. So A, B, and C are real numbers. A can be positive or negative, but it cannot be 0. Solving quadratic inequalities algebraically. All right, so the main part of our standard is about graphing quadratic inequalities, but in order to look at the graph, we're going to solve this algebraically. So the first thing we're going to do is think of this as a quadratic equation. So even though it's an inequality, it says this quadratic less than 0, but the first thing we got to do is just solve it. So get to a place to where we know what to look at. So we are going to set this equal to 0 temporarily because we already know how to solve equations of quadratics. So to do this, we're going to now factor because we're looking for a number that multiplies to give me 4, adds to give me 3, and that's going to be 4 and 1. So I'm going to have 4 and 1. When I multiply to get a negative number, I know I have to have opposite signs in my factors. And because my middle term is negative, my bigger number has to be negative. So hopefully you have practiced factoring. This is something that you can do quickly. And then we have to set each factor equal to 0 using the zero product property, which hopefully you've heard me mention a few times. All right, so if this is a quadratic equation, now we have the x-intercepts, we have the solutions of the equation, but we are looking at an inequality, so we're not quite done yet. So what we want to do is make a number line, and on that number line, we want to put these points. So let's put 0, because 0 should always be on a number line. We're going to have -1, and we're going to have 4. Now, this says x squared minus 3x minus 4 less than 0. Remember, if it's less than or greater than, it means these are not included in the solution. So what we're going to do is make open circles here. These points are not included in our solution. So what we want to do is now we have divided the number line into 3 parts. Everything that is less than -1, everything between -1 and 4, and everything greater than 4. So what we want to do is pick a point in each of these areas. These are called our critical values. Okay, they're critical values because we know that these numbers come from solving the equation here, which means that it's going to separate our solutions from our points that are non-solutions, basically. All right, so if we choose a number less than -1, we're going to plug it in, and we're going to see what we get to see if that part below -1 is actually a solution. So let's look at our calculator, and we're going to use our calculator just to plug in. We're going to use this equation. Even though it's an inequality, we're going to use this equation to see if this number is less than 0, equal to 0, or greater than 0. So -2, so we're going to do -2 squared minus 3 times -2, and then minus 4. And so that's a number to the left of -1, so we're trying to see if this area is our solution set, and if it's less than 0, then that would be our solution set. So the answer to that is 6. 6 is not less than 0, so we know this area here is not part of the solution. All right, now let's check the part in between -1 and 4. So let's plug in 0. That's easy to plug in. 0 squared is 0, minus 3 times 0 is 0, and -4. -4 is less than 0. So that shows that this area is part of the solution. So I'm going to take and I'm going to make a line here that represents this is part of the solution. So my number line doesn't look great. And remember, the open circle says that -1 and 4 are not solutions, so it's just the numbers in between. All right, let's check the other region. So let's check a number greater than 4. So let's take 5 squared minus 3 times 5 minus 4. Is that less than 0? It is not. 6 is greater than 0 again. So this is not part of the solution. This over here is not part of the solution. So the solution set would be all the numbers in between -1 and 4. So those x values, if you plug these x values in, they will give you a number greater than 0. All right, we can write this as x is in between -1 and 4. So that would be our solution set algebraically. This is graphically. This would be our solution set. Remember, the numbers on the end are not included. So that would be it. All right, B part says x squared plus x minus 6 greater than or equal to 0. Again, we're going to first solve it like it's an equation, even though it's an inequality. And that's just so we can use our skills that we already learned to solve it. So we're going to say, write this in factored form. I'm going to say x times x is x squared. I need a number that multiplies to give me -6 and adds to give me +1. So I know 2 and 3 multiply to give me 6. One has to be negative, one has to be positive. The middle number is positive, so I need a +1. So this one has to be 1 larger than than 2. So 3 is larger than 2, so that's how I decide which one gets the positive and which one gets the negative. You can always double check. X times x is x squared, plus 3x minus 2x gives me +1x. -2 times 3 is -6. All right, now set each factor equal to 0. I'm going to add 2 to both sides. X equals 2. Subtract 3. X equals -3. Now, again, this determines our critical values, which allows us to put those numbers on the graph or on the number line. So I've got a number line here. And I know that this is going to be greater than or equal to. So this time, the critical values are included in the solution set. So I'm going to have shaded in circles or closed circles. And then once again, I'm going to choose a number to the left of -3, in between -3 and 2, and to the right of 2 to figure out which area is the solution set. All right, so again, we can take our calculator and we can do this. All right, so we're going to have x squared. So let's choose a number like -4. It doesn't matter which number to the left of that, but I just usually choose a smaller number. Make sure it's in parentheses because it's negative and you're squaring it. So plus -4 and then -6. We want that to be greater than or equal to 0. 6 is greater than or equal to 0, so that would be part of our solution set. So we can say that this is going to be shaded here. All right, now we can check in between -3 and 2. So let's choose 0 is always easy. 0 squared is 0 plus 0 Negative 6 is less than, not greater than or equal to 0. So this area here is not part of the solution. So let's choose a number like 3. So 3 squared plus 3 minus 6. Again, just plug in a number to the right of this critical number into the equation to see if it's going to make a true solution here. So 6 is greater than or equal to. So it is a true solution. So we can say that this area is also part of our solution. All right. All right, so that is how we look at it on a number line. And then to represent our solution, we're going to say that x is less than or equal to negative 3, or x is greater than or equal to 2. So that would be our solution set for B part. All right, I want you to take a moment, pause the video, and try to do C on your own. You're going to do pretty much the exact same thing. Look at it as an equation. Put your critical values on the number line, and then see if you can determine which part of that number line represents your solutions, and then write those solutions algebraically. All right, hopefully you took a moment and tried to do this on your own. It's a good way to check to see if your understanding is where it needs to be. So if you did that, you should have got x equals negative 1 and x equals negative 5. Those would have been our critical values based on the equation we wrote from the inequality. So our critical values, negative 5 and negative 1, you would check a point in each of the 3 regions on the number line and then determine which area represents the solutions. The solutions are the area that makes the inequality a true statement when you plug it in. All right, so that's all for example 1.